Enough of that. Enough of that stuff. Let's just go live. Let's just go live. The screen's clean enough. Make sure that I actually have sound. Is that such a massive delay today? Or is it? Or is it? Or is it? No, it's not. It's not a massive delay. There we go. Hello, everybody. Hi. Hey, hey, hey. Hey, what do you say? Oh, let me get comfortable in the chair. These holes in the floor. I am printing new covers. There's two of them that need new covers, so I'm printing them. One's printing on the bamboo on the end over there. How's everybody doing? I'm gonna see who's here. Jerry's here, of course. Jerry, another CG Tuxedo, SPC 3D Betty Boop. David Walton, Guy the Jedi, Tuxedo Guy the Jedi, another CG. I'm repeating names. Go to adjust the clock on my car. Yes. Don't forget, we sprung ahead for those of us that do spring ahead. I don't know if they do that in Vegas. Do they spring ahead? Anyways, we sprung ahead. We lost we lost an hour of sleep last night, so I may just end up falling asleep on stream because of that lost hour of sleep. Hey, Tulsa Skin. Hello, hello. And you do flip them ahead in Vegas. Yeah, BC, next to us, British Columbia, they put their clocks ahead an hour and they're leaving them now. They're sticking to daylight savings. Boom, done. They're one of the smart provinces that said, enough of this crap. Let's stop changing our clocks. Let's just keep it the same time. You know, it's 2026. Let's grow a pair and just make the decision to stop changing clocks, stop confusing everybody. So let's do it. Yeah, wouldn't that be nice if the rest of Canada followed suit? It would definitely be something nice, wouldn't it? Anyways, we finished off last week. Smart people there. They are smart people. We finished off last week with the flashlight, and I actually just finished it off camera because, but I'll show you what I did. So basically now we have the front-facing light, which works just beautifully. And now on the side, we have the side-facing light, which is not as bright because it was dimmed down because of the LED controller that's in there. So this thing is complete. It's heavy, it's complete, it's a weapon, it's a light, it's whatever you want it to be, but it is complete. So it was just a matter of wiring the LED chip so it would slide in the side here. So the LED chip just slid right in the side, and then I've got the wires going underneath the chip. Well, the wires it's wired down at this end. Is that even going to focus for me? It's wired down at this end. Here, there we go. And then the wires are running up behind the chip and then into this little gap in here. Chris left a bigger gap in here because actually I put a JST plug on it and I wanted to push the plug through here to wire it up to the rest of the thing in here. So it goes from the LED to the LED control board, and the LED control board to the switch. And of course from the switch we've gone to the PD controller, etc., etc. So this is all finished. So if I flick the switch down, we get our side light. If I flick the switch up, we get our top light. Here, I'm going to blind you in the camera. There we go. Off. On. Look at that. I like how the camera adjusts to that. Now it becomes a spooky light. And then the side one, just there. Look at that. Cool. So that is done. Done. I'm gonna make another one of these. I just have to print the body of it and print the parts. But I do want to make another one of these because I do have the LEDs, I do have the battery, and I do have the all the electronics. Of course, you never buy one of the little electronic from AliExpress. They sell in 4s, 6s, 8s, 10s, 12s, whatever it is, right? So there we go. The controller bone is connected to the battery bone. The battery bone, the LED bone, is connected to the controller board. You know, I could get into that little rhyme. Can you turn it off remotely with the phone? No, hey, Chris is here. Hey, how are you? Mwahaha. So your light is finished, as you probably saw. I did end up switching out the screws to these, oh, I forget what you call them. Turns out I did have the right ones. They just look big. These are the truss head screws. So I did end up switching out the screws that I put in here to the truss heads. So we have a truss head here, we have a truss head there. I probably shouldn't have done it, but I put a truss head here. And then I put the truss heads, I put all 4 of these as truss heads, and that's in there extremely tight. So it's awesome, man. So we are done. So we're going to do another one. I just haven't decided what color to do it in yet. So we will charge this up. Because it's got the BMS in it, I can plug it in, and there's no indicators to what my percentage is at. But it's got a battery overcharge protection board in it, so I shouldn't have to worry about it overcharging. So there we go. Okay, let's see who else is in chat. We can say hi to. Timor is here. If I miss you, forgive me. Let's see who else is here. Steve, aka Steve Alpha, is here. Metric, what size? These truss screws I got are number 8. They're number 8, and I've got everything from 1/2 inch up to 2 inch. Now, there's nowhere on this that I'm going to use a 2-inch truss screw, so don't worry about that. But the next, and then also, so then we also finished building these little 10,000 milliamp power banks. Okay, so we're going to take Imperial. Yes, they are Imperial, just like the margarine, although I don't eat margarine, but Imperial as in the margarine. So we're going to take this, and we are going to make a bigger power bank now, based again on Chris's design for his power bank, which is the link to his design on the power bank we're going to make is pinned in the chat. Not pinned in the chat, it's in the description of the video. Number 8 is about 4.2 millimeters. I'm not that precise. So what I have done is I printed a few different bodies. Okay, these prints turned out so nice. So here, I'll show you the website. I'm pretty sure I have it up here still. It is right here. So I'm going to show you here. How do I cut to the, oh, there it is right there. So here, let me move this out of the way. So there is the 64 watt hour dual PD power bank. Now it's a dual PD, or you can make it a single PD. I'm going to be making it a single PD because I do want my displays to be able to show me the percentage of battery, etc., that's left in it. And so yeah, this is Chris's design. And again, we built the body out of PLA. Well, in my case, it's going to be ASA. And the end caps and everything else is done out of TPU. Okay, and then so we use the same battery we did in the flashlight, and we have a little bit of a different BMS here. Okay, I've got some of those BMSs. It's incredible how fast stuff is coming in from China now through AliExpress. Under a week to get these in. So there we go. So we're gonna go ahead and check this out if you want to see what we're going to be doing here. I'll be putting my build up on here. I'm going to be taking some pictures and listing my build on here pretty soon. Hey, Clown Hammer. And then we're going to go from there. But this is what we're going to build tonight. So, yeah, so that includes that, yay, and yay. Okay, so yay and yay, and nay and say. So I'm going to switch back to me, of course. So I printed a couple pieces here. So these ones are in Polymaker's, the Fiberon ASA CF8. So 8% carbon fiber ASA. These things are strong. They're extremely lightweight, surprisingly lightweight. Important thing, screws, 3D prints like this, be modified truss head. You want a coarse wood screw thread to get a nice bite. Yeah, exactly. And you don't, and it less chance of cracking, I suppose. But you do get a nice bite. They tighten down extremely tight. So yes. So here, have a close-up look at this. This is the ASA carbon fiber CF08. Fiberon from Polymaker. I mean, look how clean that print is. I mean, even the inside of the thing, beautifully clean print. This is the gray, of course, duh. And then this is the this is called Desert Sand, I believe. Yeah, Desert Sand. Same thing. This is the ASA carbon fiber CF08. desert sand. Come on, focus in there for me. Let's just do this. And come on. You don't want to focus on the desert sand for some reason. But again, beautifully clean prints, and these things are light as a feather, actually. The interesting thing about this carbon fiber filament is it's very, very brittle filament to work with. It is not recommended that you print it using an AMS, because the actual filament itself, here's one. This is the dark red. I wouldn't mind printing one in the dark, in the dark red. What am I doing here? So this is the same stuff. So it's a Fiberon ASA CF08, 8% carbon fiber reinforced ASA. This is the dark red. You get they're 500 gram spools. But I'm going to show you the secret to these and why they don't recommend you run them through an AMS type thing. You could run them through, I'm sure, a multi-head printer. But let me just open this and show you. The dark red is beautiful, by the way. I do want to do one of these in probably the next flashlight will be in the dark red. Which end did I open? I think it was this end. So yeah, look at that color. That's a beautiful color. But the one thing about this filament is, and it's not because it's dry, it's just the nature of the filament. If you look at the filament, and I can just go boom, and that's it. It's very, very brittle. It's a very brittle filament by nature right off the spool. And that's sometimes a sign of standard PLA that your filament is too wet and needs drying. But in the case of, let me put this away. In the case, and I know I opened the wrong end of the bag for anybody that was observant enough to notice. I did open the wrong end of that bag, but that's okay. There we go. So let me put that back. Yeah, so when you have your piece of filament like this, all it is just boom, and it just breaks so easy, which begs the question, how do you know when this stuff needs to be dried out? How do you know when it's wet? Anyways, that's why you don't run it through an AMS type system, because going through all the twists and turns and bends, chances are a little piece of that's going to snap off and it's going to clog your AMS. So hardened, yes, you do need a hardened nozzle for that stuff. It is carbon fiber reinforced, for sure you do. You do understand brittle filaments are heavy objects. You're likely to drop is not a great mix. Well, of course, but I don't know, well, we can test it with one of these. I don't know how this, I will do that because I don't need two gray ones. I did, but we'll do a test after. As far as strength goes, this is extremely strong, but we'll do a brittleness test after. We'll actually take this and we'll give it a torture test and see how easy it shatters. I think when it heats up and prints, it strengthens the actual strength of the filament. We'll see. Could you print the caps in TPU? I bet it'd be fine. Yes. You know, it's all yet another Dan. Oh, hello, yet another Dan. I don't recall knowing you. Coincidentally enough, here's the caps. Coincidentally enough, there's one set of caps, and guess what they're printed out of? Guess what they're printed out of? TPU. And they're beautiful, beautiful, beautiful prints out of TPU. This is Polymaker TPU 95A. Okay. Beautiful TPU. There's one set of caps, and guess what I did? I had some red TPU here, so I printed a second set of caps out of red TPU. This is a brand from, I forget what brand this is. It's just some TPU I had sitting around. Didn't print as clean on the inside, but the outside prints of these are great. They're great. So, and I thought red would look really cool, which maybe it does. Let's just see. Oh, look at the red and gray combo of that. Oops, look at that. That's beautiful. And then I thought even possibly the red would go nice. Maybe not so nice on the desert sand. Let's throw that on and see. Maybe not as nice, but I thought the red was kind of nice. So I think the desert sand deserves the clear. And the red So if I take the red off of there, a little tighter threading on the desert sand, and I put the clear on here. Oh yeah, I think the clear for the desert sand, and then the red for the, and then the red on the gray is the two that we'll make tonight. Let's just have a look. Yeah, I think definitely we want to go red and gray, clear and sand. Yeah. With dark green caps. Oh, I don't have any dark green TPU, but if I did, I would. The only difference is that this one just seems to have a bit less of a taper than this one, so it doesn't quite cover the taper on the actual model as good as the other end, but that's okay. We're going to work on that. We're going to look at that. So we have two sets of caps. We have two models, and we're going to build. Oh, and the other thing, of course, that we need, which I put, where are they? Where did I put them? Right here. These all arrived to me on Wednesday, and I ordered them just the prior Thursday, I believe. There's one of them open here somewhere. Doesn't matter, I'm going to open two of them anyways, but this is the other thing we need, is this is the BMS. This is called, I don't even know what they're actually officially called, because I cannot read the writing on the back of these things at all. For the life of me, I need a translator, but this is what we're going to be using to control this charger, is one of these little guys right here. So we have our tester switch to give us the percentage. We have a USB-A input. We have a USB-C input. And yeah, very, very cool. Not Ryobi green. I have Ryobi green, but it's not TPU. The Ryobi green I have is the glass-filled high temperature PLA from Polymaker. So, yeah. Elegoo has a black TPU. I don't know if it's 95A. I don't even know if this red one was a 95A TPU I used. I know it's very stringy compared to the other stuff, but I think I've had this around for a while, so it could have had a little moisture in it. And there's a few little snots on this thing that I'm going to have to cut off, which, not a big deal. But, and there's a little bit of stringiness that happened on it, so I can burn the stringiness off no problem. But they'll still work, but as I say, these printed so clean. And but this one, yeah, we had a little bit of an overhang issue here. I'm guessing TPU does not bridge as well as other filaments do, because there was no supports in here. So I'm just going to cut off a little bit of this yucky stuff here in this one spot because of the overhang. Because I suppose I could have possibly adjusted the speed in that spot, but yeah, I just find TPU does not bridge too well. So let me just cut that little piece off, and you'll never even know that there was a bridging issue with it when I'm done with it, because boy, I can clean these things up to make them look so good. Come on, get in there, you little nippers. There you go. And there, just like giving a little bit of a haircut, and there you go. Just like that, you'd never know there was an issue in there. See? That's why those holes are bigger. They need to be the best to account for the sloppy overhangs. Exactly. So there we go. I considered printing support for it, but no. Although there is a TPU support material that you can get from Bamboo, which is specifically for TPU. But I thought, you know what? It's a little hole. You trim it clean, and it works fine. And this one worked out. The overhang for the USB-C worked out great. There's our little test button hole, and there's our USB-A hole. Did that, was that me, or did that sound nasty? The USB-A hole. Oh, there we go. Try not to use support for TPU unless it's a different polymer. Oh, of course, yes. They have, I believe they have a material specifically meant to support TPU, which is a different polymer, which, yeah, they have a few different support materials. Maybe they don't. Maybe I'm thinking they're ASA support. That could be what I was thinking. Maybe there's no such thing as a dedicated TPU support. I could be wrong. So, well, let's start building. This build should be easy, because really all we have is one board, some wire, and some end caps. Okay, so this one end cap. Now there's two versions. The version that Chris shows on his Maker World post has two end caps with two of these boards, one board in each end, so that you can charge two devices, or you can actually put two chargers into your power bank to double your charging speed of your power bank. But as he said, is that if you use two of these, and he clearly states this on his page there, that the meter that's showing you your battery percentage, drain and usage when you're plugging and charging things or charging your battery, if you have two of these in here, this becomes useless, null and void, nothing, you just ignore it. If you have one of these, which I'm going to do, this will be accurate. So there we go. Hey, 3D Medic Vince. So that's what we're going to do. We're going to do the one end. Hence why I printed one of each cap here, and then one of the two of the other end caps. So let's get building. And these use this C34 battery, C40. Sorry, I don't know why I said C34. C40 battery. These uses the same C40 batteries that we used in the flashlight. So these are C40 lithium ferrite polymer, whatever. Don't tell me. I don't know what that means. Lithium ferrite polymer 4 years. I have no idea. 20 amp hour batteries. So these, you should get quite a few charges of your phone out of one of these. I would think that you could probably charge your phone for a week with one of these. So might take half a dozen charge cycles for that display to become accurate. These things aren't usually plugged in. Oh, okay, fair enough. I'll be using this and we'll be charging it, and we'll check it out. We'll check it out. But again, this board does have overcharge and undercharge protection built in, so we don't have to worry about that. It's not going to undercharge or overcharge your battery. So I think I said that correctly. There we go. 20,000 milliamps, so about 4 times an iPhone battery, or accounting for losses, 3 charges. Why is there something in the way of my chat here? Let's just see what's going on. And close you. There we go. Oh, about 3 charges for an iPhone? That's all. I would expect more, but we'll see. We're gonna put that to the test. So we need some wire. So we are going to use, if I can find it, it's probably right in front of me. It was right here. Right there. No, that's not the wire I want. We want to use, now Mr. Chris did suggest 20 gauge wire, but we are going to use, because I have it right here. Aha! We're going to use 18 gauge, which should fit. 18 gauge silicone wire. Okay. 5,000 milliamp battery in the typical iPhone. Ah, okay. That's why with this smaller charger, this is a 10,000 milliamp, and I tend to get 1 3/4 charges for an iPhone out of this guy, because we're doing 10,000 milliamps here, and this one we're obviously doing 20,000 milliamps. Okay, so we're going to use some 18 gauge silicone wire, which I just happen to have a couple pieces here. So we'll pull the red and the black out, so we keep or should I go white and yellow just to really mix things up? Yeah, I think I'm going to do that. I'm going to save the red and black, and I'm going to really confuse myself and do white and yellow so I can confuse, because I'm running low on my red and black here. So we're going to do, we'll do yellow as the positive. We'll do yellow as the positive, and we'll do, let's do white as the negative. There we go. It's my charger. I can do whatever color I want. Don't give me any hassle about, oh, you should keep it standard red and black so you don't mix it up, because I like to live on the edge. Missing the show as you wait eternity in Subway for a pickup order. Okay, another CG. You just wait for that Subway. It's important to get your nourishment in. Okay, so without further ado, I'm just going to, I haven't even watched any instruction on this, but this is pretty simple. We have on here, we have a plus input and a minus input. Okay, we have a battery plus, a B plus, and a minus input. So obviously negative to negative, positive to positive. If you have heat shrink tubing, you can run out black and red links in the ends of those wires for identification. That'd be too easy. I'd rather just go, I'm going dark is yellow, bright is white, right? So dark, oh, maybe the white should be positive. Nah, I don't know. We'll see. Maybe the heat shrink thing is good so I don't get confused, but you know, we're going to see. So we already know from last time that on this particular battery, the end with the label, on my case, the end with the label is positive, and the end with no label is negative. And also there's a little QR code thing here, and the negative end has a little round circular doomer hickey thing here, whatever that's for. It almost looks like it's a circuit breaker that you pop in, but it's not. So verify, yours were different. Oh, okay. I think I did verify this, but I'll do the verification. We will make sure, because yeah, these things are, yeah, we should verify so they're predictable. So let's do the verification. So there's our meter. Can I get the camera closer to the meter? There we go. Here, let's lean the meter. Let's lean the meter on here. There you go. So this is one of those automatic meters that will automatically know if you're testing for resistance, voltage, or whatever. So we touch the ends together, make sure that we are getting a reading. There we go. We got continuity. Okay, so we're going to do the negative on the bottom of the battery, and we'll do the positive on the top, and we get 3.316 volts. Okay, so 3.316, whereas if I reverse these, we're getting negative 3.31 volts. So we know that we don't want a negative voltage, so we know there that that is definitely the positive side, the top with the label. And we're looking at a 3.2 volt battery, you get 3.31 volts, so we're not quite fully charged, or we might be fully charged. I'm sure these batteries aren't fully charged. But, so we know on this particular battery we're going to use that the top is the positive. Now, let's use let's do the desert sand one first. So there's two pieces to go in here. So desert sand was going to go with the white, with the clear. Full charge is 3.65, so we definitely need to charge these after we get them going. But will you remember in 6 months? That, you know, that's a good point, but, well, I'll just be able to look at the board and see what color is attached to the positive and what color is attached to the negative. In a perfect world. Who says my world's a perfect world? Oh, we'll move this to the bottom. No, that's where the thing, there, we'll leave that there. So if I'm not mistaken, this ring goes in first. Boom, like so. Rests on the bottom. We're going to wire it up, but right now I'm just doing a fit. It's called my fitting test. Battery goes in positive up, like so. Hang on a second here. Like that. Oh no, I think, okay, maybe this long one, oh, this long one goes in on this end. Or does it go in on this end and then the cap goes on? Let's just see. No, because this is where all the controls are going. Hang on, I gotta sneeze. Hang on. Excuse me. Whew. Or a Sharpie. Oh, I got it. That's it. I got it. So we go in like this. This goes on this end because that's going to snug the battery down. We have a split here where the wires, or for where the wires are going to go. So the wires come between that. TPU on both ends of the battery for shock absorption. And then this guy is going to go in the end cap like this. Let's see. Oh no, not quite. It's got to be the other way around. That's too tall for this side. Oops. Hang on, my camera. There we go. That's better. So this one should... Okay, so hang on a second. Maybe it goes the other way around. Does it go this one in first? Then the battery? No, definitely not. No, it's got to be the other way. Driving you nuts there, aren't I? So this one goes in first. Come on, sit down there properly. Washer. There we go. Then the battery. And then this one. Why? But that seems to be pretty... That doesn't allow the cap. Unless that's got to go in the other end. Oh yeah, well the battery is sitting in there nice and snug now, actually, so that's probably right. Okay, and then the electronics are going in on this end, like so. And then this is the end cap. So this is sort of, but I thought that would tighten down a little more right there. Oh, I have them backwards. Oh, okay. Okay, I have them backwards. Oh, okay. Okay, so this will go on this end, like so, and then this, no, no. Swap the end cap. Oh, swap the end caps. Oh, I get it. So keep it the same, but swap the end caps. Okay. So like this, like this. Ah, like that, and then this end cap. Oh, I get it. Okay, I got it. I got it. There we go. That works. Okay, that works. So we have like that. Okay, perfect. Okay, let's get some electronics going. Okay, so this goes in here like so, and we can take this one off of here. Now, depending on how soft your TPU, you may need to adjust the height of the stack insert. Ah, okay. Yeah, I could actually chop a little bit off of that. Maybe. We'll see. Okay. So now we have to run. So the battery, I'm going to put the positive end to the top, and we'll put the negative to the bottom. Okay. So we're going to run boom, boom, boom. So we're going to have the electronics are going to be up top here, like so. We're just going to make sure we do this right. Oops, get my hand out of the way. And let's zoom this out a little bit here. There we are. So this will be the electronics part. So we're going to have to take, oh, that closes up a little better there. So we're going to take a positive one, nice and tight. So we're going to take a positive. I was using 80A, so yours squishes a little more. Ah, there we go. But this will be fine. So we're going to need to run a negative, so the bottom is negative. We're going to run a black wire from the bottom up. And because we're only doing one, we just got to run the black wire from the bottom of the battery to the top. So our negative is going to be, I'll make yellow the negative and white the positive. So we're going to run, I'm just going to cut a little more length than I actually need off of here. I'd rather have too much than too little. And I will use the shrink wrapping idea, come to think of it, just to be safe, as you guys say. So we'll make the yellow and we'll put some black. We have some heat shrink tube here. We have some black right here. We can just stick a piece of black heat shrinking on that. And we got some red. We can stick a piece of red heat shrinking on the other one. Is this going to be the right size? No, I need to go a little bigger. I don't have any bigger red, but as long as I can just mark the black, that's all I need to mark. At least that way I know the black is the negative. Have to rotate the cap. Yes, absolutely. But there's lots there. There's lots of extra there for that one. And then all we got to do is come from the top of the battery with the positive. And so we don't have to have as much room. So let's go ahead and strip the end. And let's see, I wonder if I could use these same clips for the end of this battery that I did before. Yeah, I suppose I could use those same ones on the end. I don't have any of the circular ones that go around. We're going to be using M6 hammerhead nuts to tighten the wires down on here. The M6 hammerheads work perfectly because that's all I have for M6 nuts is these hammerheads. So that's what we use on the bottom here. Okay, oh, by the way, you guys, I did pin a link to the top of the chat to enter the Polymaker draw, and it's also a link in the description. So go ahead and enter to win some Polymaker Filament if you would like to. We're going to do that draw in about an hour. So let's strip some wire here. Actually, we're going to use that plug, so I'm going to double strip this. I don't know where that went. Just use a washer, that's what you used. Oh, really? Oh, but this is more fun. This is more fun. I can use that. I can go up that way. Yeah, and actually that's going to be too far. Actually, that's going to stick out too far for this. Disqualified if you entered the draw more than once. Yeah, actually, you're right. If you enter the draw more than once, disqualification. So make sure you enter the draw only once. Do I have an M6 washer now that you said that? Let me get this out of the way. There's a good 8-pound plate. I got to get out of the way while I look for my washer. That's a whole other story. Although I'd be impressed if anybody out there knew what that plate was for. I do not have any M6 washers. Do I have an M6 lock washer? No, those are M5s. I have no M6 washers. Let's see. Nah, oh, you know, I may have an M6 washer over in my other stash. Anyways, if anybody can tell me what that plate is for, I would be very impressed if you knew what that was for. There we go. Nothing to do with automotive. Oh, here, let me hold it up in the big camera so you can see. It's stainless steel. It's about 8 pounds, and it's bent like so. It's got a whole bunch of different holes and areas for attaching different things. There we go. But the tube with caps end look like pipe boom boom. Oh, they do, don't they? Yeah, they do look like pipe boom boom. I'm not going to say that word, but I know exactly what you're saying. I'm just over here. I'm going to look. I have some M6. I have an M6 kit here, I think. M3, M3, M2. What do we have here? M5, M4, M3. I got everything but M6. That's okay. I think for this I can just wrap bare wire around under that nut. I don't want to tin the wire, of course, but yeah. Bada boom, bada bing. It's a backpack thing. I'd be crazy heavy though, but I could see getting strapped to a back. Yet another Dan is the closest so far. You are correct. It is something to do with your back. Something to do with your back. Okay, where were we? We were on our negative here. Can I just wrap? I guess I could just wrap it around and tighten it with a nut. Because until I get the proper... But that's the beauty of these things. You can always take them apart and fix them up at a later time. Playing another fun game of how did that happen? A prosthesis? No. Think about, I'll give you one hint. See how well you guys know me. Think about what one of my hobbies used to be. Voyager. Mark, how did you know? It is a back plate for a BCD, for diving. And the nice advantage of that back plate is that it's an 8. No, I don't like the way that's going to work out. I don't have a washer. I'm going to make it work with this thing here. The nice thing about having a back plate that's 8 pounds is that alleviates a lot of weight from your diving gear, from your having to put extra weight, because you already have an 8-pound back plate. So, exactly. Good one, Mark. You win the prize for guessing what it was. And you're never going to guess what your prize is. You're never going to guess what your prize is. You know why you're never going to guess what your prize is? Because there is no prize. Snip off the red plastic. Yeah, I'm going to do that. Yeah, I'm going to do that. Actually, if I do that first, it'll make it easier to get this thing on. Here, I got to switch back to this. Let's get this off of here, like that. Where's my little pliers? Let's take this off of here. Da-da-da-da. Hey, Scrim4713. Hello, hello. There we go. Then we'll put the wire. I don't need the wire that long. Come on. Okay. I always get nervous doing electronics live for some reason, because it's like, what if I screw it up? What if people laugh at me? What if they think I'm doing it wrong? Well, too bad. You do better. Which one's going to squish it the most? The red one. This may not. No, I'm going to have to squish that with something different. Let me grab some different squishers. This one will work. I have squishers for every occasion. Let's see if this will do it. And we unlock it. And that should have done it. Oh yeah, that squished that way. That squished it real good. That squished it real good. Okay. So we're going to put this under our negative screw. We're going to screw this in. Make sure this is screwed down good and tight. It's hard. I'd rather use a wing nut because I can get a better grip on a wing nut, but when you don't have a wing nut, you just have to deal with whatever you have handy. And there we go. And that is on there good and tight. So now we're just going to run that up through the holder, and we have little grooves that he's cut out on the side. You can see there for the wires to slide in. We wouldn't keep quiet to watch the sparks fly at the end, would we? No. Uninsulated terminals are easy to crimp. Make more reliable crimps too, of course. Okay, so let's do that. Let's slide that in like so. Oh, that slides in like a glove. Look at that. Then we have our negative wire coming out. Okay. That's good. So let's pull that out a little bit. Let's get a positive wire hooked up here. So we're going to use white as, and you know how I'll remember white is positive? Because when you're dealing with some household electricity, white is your live wire or your hot wire, if I'm not mistaken. I don't know anything about household electricity, so that's just that's a pure guess. And no, I'm not going to be wiring my house up anytime soon. Okay, so the white wire, we don't need a big piece, so probably just something like that. As you know, as he said, we need to be able to twist the cap, so we'll do the white wire next. White is neutral in household electronics, is it really? See, shows you what I know. Well, you have white and black, don't you, in household? White is neutral. Okay, well, in this case, white is live. Well, what can I tell you? It is now because I've already run the yellow wire down to the negative end of the battery. And with that done, I can actually, hang on, I've got this backwards again, don't I? Oh, no, I'm good. I can put the cap on the negative end now. I can put this cap on because the top is where the electronics are going to go. So I can put that on because I can still slide the battery in and out. There's no positive or negative. I'm positive that you're right about being no positive or negative. So for now, we're just going to get this terminal for the white wire. And I'm going to crimp this one. Where's my crimper? Come on. Make sure that goes in there and it stays in there. We'll crimp this. Which one am I going to use? I'm going to use that big one there. Crimp that one, or taped red. Yeah, I don't get much into household electronics. I can do basic wiring in household electronics, running an outlet, running a switch, but for the most part, leave it to the experts. So that's a nice little crimp right there on the white wire. But let's just see, do I actually have, and now I'm thinking that you guys are going to say, oh, you should, blah, blah. Okay, but I'm going to see if I can find a little piece of red shrink tube. And I can put a little, see this little red stuff is too small. Let's see, is this, it doesn't have to, I don't even have to be able to shrink it. No, it's just a little too small. And then the only other size I have is this one. So I could just take a little piece of this red, just like so. Okay, and let's grab the heat gun here. And let's put a little piece of red. We'll just put a little piece of red up near the battery end like this. Just put a piece of red by the battery end, and that way I will know that that's my positive coming off when I open it up. That's all I need, is just a little indicator. There we go. And even if it slides up and down a bit, not a big deal. There we go. Okay. That appeases the masses. Okay, so we'll slide the battery out. We'll get the red terminal hooked up. Okay, that's going to be perfect. We're going to make sure we don't strip the negative yet, because with my luck, if I strip the negative wire, I'll end up touching the two together. And I don't know what would happen. What would happen, Chris, if I shorted this battery out by mistake? Would it go boom boom, or would it just spark, or what would it do? Because this is a big intimidating battery. Big intimidating battery. It's like I'm building a boom boom, but I'm not. Okay, and then we'll just get this tightened up. Nothing would happen except the wire would get hot. Oh, okay. And there's our positive hooked up nice and snug. So there we go. We have our positive and our negative. Now we can go ahead and let's see. Where's the board? Where'd I put the board? Right here. So this board is going to screw into 4 little posts in here. 1, 2, 3, 4. There's 4 holes in the board that we're going to screw into. Now we have to make sure that we line up the USB-A hole. I like saying USB-A hole for some reason. Who else is here? Wire would melt before the battery failed. Oh, okay, cool. Deanna the Baker's here. Hello, hello. Anybody else show up that I didn't see? Kenneth Davis is here. Hello, hello. Okay, so we're going to line up the USB-A hole, but we're going to wire it first. And the wires are just going to come up. So we have our negative and positive. How are the wires? Is there a hole for the wires to come up through this thing? It doesn't look like there is. Let me drop this in and see what our spacing is like. There's our spacing. There's our test button. So he's got this design really nice so that the USB-A hole lines up nicely. There's our test button right there, and there's our USB-C hole. And now, when I tighten those down, where are my wires going to come up through? I guess the wires can come up through and underneath and be pinched in there. So we're going to take this out. We're going to bring these wires through. And then actually I could probably wire this thing up. I could probably just put the washer thing in here now. Giant hole right in the middle. It's Halo Dude. Giant hole right in the middle. So we have this one. We have this little break in the. We have this little break in here for the negative wire coming up the side here. Giant hole in the middle. That's a good one. And then we, oh yeah, because I can solder them to the top of it. Duh. I don't have to solder it to the bottom of it. I was not thinking outside the box. But I can put that on. Now hang on a second here. But then if I put this on and wire it up, no, I want to wire it on the bottom so that there's nothing in there. Wires go into the bottom of the board. That's what I was just thinking. Not even a switch. I know a little bit about electronics. I know you have circuit breakers, and I know you have, you know. Okay, let's wire the bottom of the board, and then let's just see. Then I can do it just open like this, and I can slide everything around it. Yeah, okay, so let's go ahead and wire the bottom of the board now. So let's make these negative and positive. I'm going to make my red one a little bit longer, just because. Space beneath the board, the wires will not be pinched. Ah, okay, makes sense. Okay, where's my helping hands? Right here. Helping hands. Oh, don't fall over. Okay, we're gonna do this again. You know, I'm gonna make 2 on this stream if I have time. Mostly I'm talking. So, I mean, you know, what can I tell you? So we're going to pinch, we're going to just go ahead with our helping hands, and we're going to, where's my positive? There it is. So we're going to just clamp this on this side. And I'll just use 2 clamps to hold this board nice and sturdy. There we go. So we got the board held nicely here. Boom, boom. We're going to pop the wire. I don't think these wires, I think I've used thicker wire, and I don't think they'll pop up through. I've got to solder them onto the bottom. So we got to turn this around like so. And then we'll solder onto the bottom of it. Okay, there we go. Let me get the first one. You should do it either the other way around, by the way, since you're doing a single and solder in the wires. Why? What keeps popping up? I don't like these pop-ups. They're interfering with my chat. And then solder, slide the wires through, then attach the other terminal. The wire is too big to go through these holes. It's an 18 gauge wire. Let's just see. I don't think it'll go through. This is my positive. Yeah, no, my wire's too big to go through these holes, so I'm just going to solder it right on the bottom like so, which should work. Remove the battery and wires. Why? You should do it the other way around, by the way. Since you're doing a single-ended solder, slide the wires through, then attach the other terminal. Because it's easier to work on. Oh, so just make these holes a little bigger? Really? Is it that easy to make these holes bigger? Huh. Well, I've got lots of these boards, so let's just see. Doesn't want to go. I got a better idea. Let's just see. Where'd I put them? No. Oh. For 20 gauge, yes. For 18 gauge, you don't know. Yeah, I don't think I'm going to make... No, I think I'm just going to do what I was going to do. I think I can just make those... Well, hang on. Let me try something. Where are my little thingamadoobers? Right here. That's what I'm looking for right here, this one. And I'm going to pull this out. All the electronics gurus out there are going to freak out over what I'm going to do here. But don't experiment, you don't know, right? At least that's my opinion. So let's just go. I have... Ooh, that'd be perfect right there. A needle file will work, so will a microscopic drill bit with a little drill bit handle. Look at this. Maybe. Why can I see myself drilling into my hand? Oh, that's not going to work too easy. Maybe that has to actually go on a drill. Here comes the blood. You guys, ye have little confidence in me. Do I have, let's see. A needle file, but I have a file here. Let's just see. I have a set of miniature files. Is one of these a needle file? That's a needle file, but yeah, that's going to be the only one that would possibly work. Because it is a miniature needle file. Bah-ha-ha. Let's just see. Blood equals content. Yeah, you're right. Little needle file here. Let's just see. Is it doing anything? Oh, just, yeah, broke the tip of the file off. It did something all right. Broke the tip of the file off. Ah. Oh, lordy, lordy. Never a dull moment on this channel. There, I got the tip of the file out. Hey, but it did make the hole a little bigger. I should just solder onto the back of the board. Why am I wasting time doing this? It'd be easier, because I'd have to go pretty big hole for the 18 gauge wire. I don't have any 20 gauge silicone. So I think we're just going to stop here and go the other way. I'll step on that tip walking barefoot one day. I wear slippers everywhere I go. And that's a shag carpet down there. Bright orange shag carpet. No, it's not. No, it's not. Okay, let's just have a look. Is that going to go through there at all? After all that work doing nothing, that's not going to go through there, is it? No. Do I have any smaller wire? Do I have any 20 gauge wire? 20 gauge would probably work. Or I could just do what I was going to do and solder that right on the back of that, and we should be good. Let's just do what I was going to do. That's what I did for the flashlight, and it worked. Right? It worked fine. Let's turn the soldering iron on. Let's get some heat going. Let's get some burning going on here. I'm going to have to disconnect the battery. Why? On both ends? Let's get the positive terminal tinned. Oh yeah, I guess I don't want to do that soldering without having the battery on. Blah blah. Okay. Let's just get this wire tinned up a little bit here. Okay, that one's done. And the yellow one, oh, this I got lots of room here. I can do this. I don't believe in easy. I like making things just a little more challenging. Makes for people sticking around more just to see if there's a chance of blood, people will watch. If there's no chance of blood or burns, off stream earlier today, anybody ever done that? You're doing something really close. Off stream earlier today, I went and touched this part of the soldering iron at 350 degrees. Wasn't the smartest thing for me to do. I shouldn't admit that on my stream, but you know, I have to tell the truth and be honest that that's exactly what happened. So it wasn't the smartest thing for me to do. Okay, yellow's my negative. yeah, and it actually, it was quick enough. It didn't really leave too much of a burn because I was quick enough to let it go. Okay, let's see what I can do here. Where'd my solder piece go? Let's just get a little bit on the tip of this. Let's get a little bit on the tip of this. And and I'm just gonna put a soldering iron in my mouth. Here. This is not safe at all, is it? No. What can I tell you? Let's hold this wire in place, and let's just give this a little bit of more support there. There we go. That should be good. Okay, we're good. That's not going anywhere. We'll do the positive one here. I'm just going to put a little bit more solder on here first. There we go. Oh, a little more. There we go. And then we can get this one on. You know, I don't have the best soldering skills in the world, but I've come a long way, I got to admit, with my soldering over when I very first did something. There we go. And this one should be nice and snug, nice and snug. We are good. We have our board soldered, no problem. That should lay nice and flat under there. Actually, I think I got a little extra solder sticking up right here. There we go. I can straighten that out. We're still strong. Your arm hit the heat gun. Oh yeah, struggle is real. Countdown to when I'll figure what out. Let's see, what did I need to figure out? Hang on, so that can go down like that. That can go down like that. You're saying figure out that I needed to put this up through here first. Yeah. Damn it. No, so all I gotta do is take it off the battery and do this. That's all I gotta do. Just like that, right? That's all I gotta do. Live and learn. Okay, so we push this in here. There we go. The wires are underneath. Let's make sure this is turned to the right direction. We have our USB-A hole here. We have our USB-A hole, our USB-C hole, and our little testing switch. Now I'm going to use where are my little M2 self-tapping screws? Oh! Just got to find some M2 self-tapping screws, which are in my yellow case. There they are. Is that them? No. Where are they? Which one are they in? There they are. Four of those. 1, 2, 3. And come on. Quattro. My hands are too big to handle small screws. Who's an A-hole? USB A-hole. Pointy M2s. These are here. These are what I'm using. Pointy M2s with my little M2 pointy driver. Yeah, these yeah. I've used a lot of these in the Voron builds, and they can be really fussy. So let's do this. There we go. So we're screwing the pointy M2s, 4 of them to hold the board in place. 1, uno, dos, cuatro, cinq, unos, dos, tres, cuatro. You get the point? Afflict a drop of molten solder right on the back of your index finger. Oh gosh. And it stuck until it cooled. That doesn't sound fun. It's funny when you said earlier, Chris, oh, he'll figure it out. And it's like, how many times have you meant to put a piece of heat shrink tubing on a wire? You've gone and soldered your wire up and realized, oh crap, I didn't put the heat shrink tubing on it. We've all been there. If you don't admit it, yeah. Took 2 weeks to heal. Ouch. There's 3 and 1 more. And where's the 4th hole? There it is. Right. Come on. 4th hole right there. There we go. Oh, CA all over your hand when you spray accelerator. Oh no. Oh, I've had CA glue all over my hands before though. There we go. So hard to see inside there, but we've got 4 screws, 4 of the M2 screws, self-tappers, holding that all in. Come on, brighten up there a little bit. Oh, what am I doing? I've got this camera. That's a much better camera. So you can see where I put the 4 M2 screws in. Okay, and on the side we've got our USB-C hole. We've got our tester, and there's the USB-A hole right there. Okay, and then there's a little cap that goes on the end here that covers all these up. Okay, so now, CA is from the depths of hell. You should see, I have a CA glue here. Hang on, I have a CA glue here. I forget what brand, but it's like water. It's got the viscosity of water. And when you use that, I use it on some of the wood projects, and when you use that stuff, it gets places you don't know how it got those. Well, it's like the path of least resistance for water, right? Oh boy, that's a nightmare to work with sometimes. Okay, so now we can go ahead and connect the negative end of the battery. Now we can connect the negative end of the battery. I'm just going to use my, tighten this up. There we go. And then we're going to slide the battery in, like so. We can take our little washer thing here with nice split ring washer here, so you don't forget to put it in. And then put that over. Let's connect the positive end of the battery first. Okay, do we have any lights on the board? No, but let's see if I hit that. No, we have nothing yet. Nothing showing yet. And positive is connected, but we have nothing showing on the board. So is there a wire that's not quite right? When I push this button, I should get my light showing me the power on the battery. Why don't I? Do I have a faulty board? I should have done that before I screwed the board in and tested it. What did I do wrong? Or is it that it's just not charged yet? Let me plug a charging source into it. Charging source into it. Oh, there we go. 100%. Now if I unplug it, nothing. But we get 100 if I plug the charging end into it. Prime it. So we're definitely not 100% charged. But you can plug that into any of these blank boards and you'll still get that 100%. So I'm wondering if I've got a loose wire somewhere. Let me just check my theory. So if I open another one of these boards, and then if I just plug a power source directly into the board, I'm pretty sure it's going to say 100%. Yeah. So we're getting that no matter what, whether the battery's connected or not. So I've definitely, one of my connections is bad. Yes. Okay, well, so what we'll do then is we'll undo the positive terminal and we'll check our connections. Okay, take that off, slide the battery out. Okay. Let's just check. Let's take it out with the negative out. Let's just check it with the battery first, just like so. And let's try now. Nope. Okay. So it's not the connection on the battery. Okay. Just for fun. Just for fun. Okay, no, not the battery. I just tried a different battery. Okay, so we have to pull this out and check my connections underneath. Perhaps one of my solder joints came loose. Or the wires are reversed on the board. No, I'm pretty sure I'm okay. I use the yellow as my, or the white as my positive and yellow as my negative. Let's just pop this out and see. And we'll test it before we put this all back in to make sure. Continuity test the wires. The wires themselves, yes, okay. Okay. Let's pop you out. And it looks like our solder joints are still in place. So, oh no, this yellow one just came off. That actually just came off the whole that ripped the connection piece right off the board. So I think this board is toast. Okay, let me heat up my soldering iron here. Yeah, it ripped the connection right off the board itself, so there's nowhere to solder on there anymore. I think that was probably from me drilling and trying to file that out. I probably loosened that board right off of whatever it is on however these PCBs work, right? So that's okay. That's why we don't just order one board. So let's just go ahead and remove this wire. Come on. There we go. Try through hole first. Well, but the wires, let me just look. Hang on a second. Let me just look. Just to save some hassle here, let me look and see. Let me just look and see. This is my wire bin. This is full of wire. Let me see if I have anything a little thinner that might work. What is this one? This is not a... Man, my eyes cannot read these wires. Let me see. Where's my phone? My phone makes a good magnifier to read the side of these wires. That could have ended up bad. I know. Hang on a second. When I do my camera, zoom in on these wires. This is a... Come on, what gauge is this? Hmm. 300 volt. It's not telling me what I want to know. 300 volts. $20? Is that 20? It's not telling me. All it says is 300 volts. Do I have jumper leads? Any jumper lead? I don't think so. This! That's not silicone though. That's not silicone wire. Oh, look at that. I have 12 gauge silicone. And I have, that's 20 gauge silicone. No, that's 18. What's this stuff? What's this stuff? Man, I wish I could see better. Mind you, oh. Well, come on, I see the AWG. What's the number beside it? And that's not going to be 20. This is going to be bigger or smaller. That stuff's way too small for me to read. I don't want to take that chance. So I have a black roll like that. Yeah, there's a black roll. The black is easier to read. No, the black's not any easier to read. What's going on? Why aren't these cheap wires that are not labeled worth a damn? Okay. I think we're going to be okay with, I know, just give me a second. I'll be right with you. There's one. What gauge is this stuff? You're not going to tell me again, are you? I got lots of this. Lots of this. Just want to see what this stuff is. I think this is 20. Yeah, okay. So I can get away with this. Let's just grab a couple pieces of this. And we have JST connectors on these ones, actually. This was an old BL Touch length of wire I used. I believe this, I'm positive this said 20. And that's lots right there. Let's just cut this off right here. There we go. Let me put this back. I'm positive this said 20. If I'm lying, I'm frying. No label on the end of the spools. No, some of these spools I get, they don't label them too well. Silicone rubber. Oh, 22. Would 22 work? Tell me 22 will work. Or should I not do 22? Is 22 too thin? It will work? Okay, good. Good. That's what we'll do. We'll do 22 gauge. But in the meantime, I'm going to, yeah, and this way I can put it through the hole and hopefully salvage this, you know, just whatever. Where's the other board here? Let's just do this. If we're going to do it, we're going to do it. Okay. If we're going to do it, we're going to do it. I'll worry about that other board later. It's a $4.29 board. Okay. This should go through this hole no problem, and yes it does. Goes right through the hole beautifully. We're going to hold it in. Oh, I realized I didn't switch the cameras yet. It's all right. You wish you were still 22. Ah. Okay, so let's go ahead and switch this over. Oh, now the soldering iron's cooling down. Soldering station I have has a safety feature. After so long, it automatically cools down the iron for me. These clippy things, I'll show you in a minute. Remind me, Chris, remind me. Ordered them online. Okay, here we go. Ouch, ouch, ouch. Oh. You're supposed to hold that still for me. Come on. There we go. Oh. Okay, so there's that. We can snip the top of that off. There we go. We got the red wire in. Let's get the black wire in. Where did I put the black wire? Right here. Lots of length. Lots of length. First blood. Never blood. That was more so hot. There's the black wire. Come in from behind underneath, and let's get this soldered in there. There we go. Snip that off. Okay. There we have our red and our black. Now let's test this out before we go too much further. Where's the battery? Here's the battery. Let's just strip a little bit off the end. We're just going to do a quick rough connect here and make sure. Okay. Just going to do a quick connect here. I want to make sure that this is going to actually work before I waste too much more time on it. Just wrap that around. Oops, come on, wrap that around, screw that down. Wrap it around, screw it down. Oh, come on. Okay, there's the black connected. We'll connect the red. Remove the clamps. Oh, there we go. Okay, let's remove the clamps. Good idea. That would have been fun. Would have been a burned out board, right? Okay, battery's connected, and then there we go. Okay, that works. So now we know we're at 72%. Okay, so this we know this is good. So maybe I had a bad board. I probably screwed it up when I tried to file when I tried to file the hole bigger. I probably screwed up the actual board. So there we go. So now that works. Okay. So now that we got that out of the way, I need to get some more terminals now for the end of the battery, or else I could just use the loose wire like I just did. I mean, heck, is that such a bad thing just to wrap the wire around the terminal, screw it on? Let's turn these around. Let's turn these around. Might not be accurate. No, that's fine, yeah, to calibrate it. Okay, so if I just go ahead and take this and wrap it and screw it on. So we are on there good and tight. There we go. Okay. Now we run this down the length of our light, like so. What's in the bottom? What's holding that? Oh, my washer. My washer's sitting a little bit crooked. Come on, straighten out. There we are. Okay. Oh, no, it's not the washer sitting crooked. It's because the wire has got to go in underneath. Oh. I need, come on, get out of there. I need to actually run the wire. No, or do I? Yeah, hang on. Hang on a second here. Oh, you're twisted in the threads. Enter the draw. We're going to do a draw soon. That'll be the most exciting part of this whole stream. Time change, yeah. Fits through without going through the washer? Oh, does it? Okay, well then we'll put it back on. Oh, okay. Hey, I listened to the designer in this case, right? Because he knows what he's talking about in a perfect world. And so we'll wrap that around, we'll screw that on again. There we go. Okay, so let's put the washer back in, like so. Oops, you flipped upside down on me, washer. Tapered end of the washer up. No, tapered end up, or tapered end down. Tapered end down. Why do you keep flipping? There, I'll flip you on. There we go. Okay. Now we'll shove this through. There we go, that's better. Okay. So now we'll put the red, since these are so, we don't need nearly that much red wire. So we're just gonna, let's cut this off right about here. Whoops, right about here. We can save that for the other one. Then we can peel off about that much wire. Okay, and then we can connect the red. Oh, I just about did it again, didn't I? When were you going to tell me? When were you going to tell me? Ah, down the rabbit hole. Down the rabbit hole. You weren't going to tell me, were you? Let's just screw this in now. Where's the USB A hole? Right there. USB A hole. Trust me, guys. The second one will go much easier. Okay. Now we can put these screws back in since we're here. Okay. Yeah, the second one will go real easy since I found this thinner wire. And I've got lots of it. I don't know if I have lots of red and black, but whatever colors I use for my old BL Touch, I have a scrap load of these wires. 22 gauge. Okay, and of course there's a third one. Yeah, you'd think I'd use one of my magnetic trays I've got. One of the 4 magnetic trays I've got over there to put these screws in so I don't lose them, wouldn't you? That would just be way too easy though. Now, did I just close out? Oh, I thought I closed out the program because it fell off my screen. Where's that last screw? There it is. There it is. Whew, we'll do the draw when I get this one put back together. We'll do the Polymaker draw when I'm done this. This is ridiculous, an hour and a half. I gotta sneeze again. Excuse me, I think I'm allergic. I need a drink. I'm just gonna take a quick break for a Coke Zero drink. Ah, it's the TPU, is it? Okay. Okay, we got this back on. We're ready to go again. Ja. And cut. And action. Okay, let's put the negative on the negative. Okay, leave me a little gap. Wrap me some wire. Come on. There we go. And tighten me up. There we are. And let's put the red on the red. Actually, put the screw on first. I knew these M6 hammerheads would come in handy for something one day. And we'll put the red on the red. Screw it around. Like that. Let's double check this before we put it all together. And we do have a light up, so it is working. Now we can slide the battery in. Okay, we'll put the collar on. Okay, we got the collar on right here. Oh, we got the collar on right here. Okay, I think that's where this goes. Actually, that's just, it doesn't work. I know, it's my bad sense of humor. Was able to unblob a death with this without messing up those wires. Aha. Okay, so we'll put this in like so, with that one going to the wire, and we'll undo this about a few times till we twist the wires. We'll tuck the wires down in the hole, and then we will screw this cap on like that. We'll screw the bottom cap on like that. We'll test the battery just like that. It says 78%. Now, if I plug a charger into it, we should get a flashing number indicating that it is charging. There we go. So now it's flashing, telling me that it's actually charging the pack. And as Chris said, we need to basically let it run a few charge-discharge cycles to calibrate itself. Whoever thought using wire as thin as hair on the thermistor needs a good shake. There we go. Okay, and now on top of this, we have our clear cap with a little window, so it's easy to know which way this goes on because the little window goes over the little doomer thingy there. And then we plug this in. Here, let me switch to this. So we're going to take this and we're going to plug this in. How come some cameras do the little flickery of the light? I guess it's to do with the frame rate, right, of the camera. And then the end cap will go on like so. There we go. So there's the end cap. There is our charger. Frame rate, yeah. So obviously this camera I'm using right here has a higher frame rate. And then there's our end cap, and we can push the little button there to activate it. And we can see our percentage right through it. There is our power bank. Look at that. I like this. That is great. And you do two of them, okay, because I'm going to be doing a second one. Dual purpose. Ready? See? Well, for the couch potatoes out there, you can actually charge your phone while you get a workout. How heavy is this, you ask? I'm glad you asked. I know Chris knows already, but I'm going to see how heavy it is on my end. Okay, turn it on. In grams, long as it's under a kilogram, because 562 grams. 562 grams, so we're at just a half a kilogram, so a little over a pound. About 1.2, 1.3 pounds. Do I have pounds on this? No, I have CT. Whatever CT is, it's 2,811. 19 ounces, okay? Don't know what these units of measure are. 8,678 grains, but 562 grams. So just a little over half the weight of a spool of filament. There we go. 1 pound, 3 ounces. So that was 562 grams, and then the flashlight is 860 grams. So between the two devices, you've got weapons of choice here. And you've got workout material, okay? Okay, very cool. CT is carrots. Don't try and make me hungry. So now let's test one more thing. So we're going to plug this into the USB-A hole. Okay, there we go. We're going to plug the other end into my phone, which is right here. And we have charging. going on. Or do we? Hang on. Yes, we are charging, and shows us 78%, and my phone is charging. There we go. Yay, it works. Okay. So that is a massively big, powerful charger. So now we put that aside, we do a draw, and then we make another one with red end caps. Red end, red end, red end, red end, red end. Okay, who wants to do a draw? Phone blows up. Ye have little faith. Ye have little faith. Okay, let's put these little micro drill bits away before I lose them. Okay. Okay, let's do a draw. So if you haven't entered, so sad, too bad. You had lots of chances. I'll give you a couple seconds. If you're new here or you just showed up or whatever, top of chat, there is a link to a Google document that you fill out once only. Any double names are disqualified tonight. And you fill it out and for your chance to win $35 US Polymaker gift card or a $45 Canadian Polymaker gift card on polymaker.com or CA. Actually, it's the new shop, Polymaker's new shop, shop.polymaker.com. Or reverse draw and drains phone battery. Oh, that's funny. That would be funny. No, that wouldn't be funny. Okay, we're gonna give you guys a couple seconds to go enter that draw if you haven't yet. You filled it out 46 times, Wiki Central, you're disqualified. Sorry, man, but thanks. Everybody else is gonna have a better chance. 46 times. 46 times. Okay, we have 45 people watching. So if you haven't filled it out yet, you're gonna have a few seconds to fill it out while I throw some wires here in the garbage and while I clean up a little bit of my mess here. I'm just killing time for those that were slacking and haven't filled out the form yet. And then we're going to build another one of these power banks and then we're going to say adios. But why don't I? Well, we build one. Why don't I just plug this one in to charge it? Let's give it a full charge. There we go. We're at 78%. Let's see how much it charges by the end of the stream. Okay, a little more. Oh, somebody asked about this tray. So this tray, unfortunately I'm missing one of the rubber feet, but I should just print another one. This is, you can Google it. I don't remember exactly when I got it or where I got it, but this is called It's called an Omnifixo tray. Omnifixo. And it's got like a little ruler on the bottom, little millimeter ruler, patent pending. And it's got like an inches ruler along the top. It's got little rubber feet on the bottom. These little guys, it's got these little clamps that you can use, and you can stack these. So you could actually stack these, if you wanted to, you could stack these 3 and 4 high. Comes with the 4 clamps, and it's actually my favorite helping hands thing that I've ever gotten. These are magnetic. They got a little ball end here, and they goes into this so that you can rotate it in any which way you want. It's a really, really cool little device. So there you go. The top and bottom clamps are insulated, except on this one, I lost the top piece of insulation somewhere, somehow. I guess I could make another one, but yeah, they're just these little pieces of rubber tubing that go on over it. And I lost one along the way somewhere, but the rest of them I do have. They are insulated. And you could take it off if you don't need the insulation for whatever reason, you can take it off. But yeah, I don't see any reason to, but I don't know how I lost it. I just lost it one time, so yeah, that's the way it is. So sad, but that's life. That's life in the big city. Take a piece of heat shrink tubing on there. Yeah, that would work too. That's actually not a bad idea. Because I have tiny heat shrink tubing. I'm killing time to let everybody enter the draw, just so you know. But by the time I'm finished talking, if you haven't entered the draw, you're done. So let's see that one there. Oh, that's a little too small. This red one might work. Oh yeah, if I did that and I shrunk the heat shrink, let's see if I do that. if I do that and then I take my heat gun and I heat that, that might just work. Oh, that's hot on the fingers. I said that's hot on the fingers. Okay, that. Look at that. What a good idea, Chris. Look at that. It worked. It worked. Yay. Cut that little tip off. There we go. That's fixed. I could make them all. I could do them all different colors. Color themed. Look at that. Awesome. Brilliant idea. So you don't like this video, you cat poop instead of filament. There you go. Okay, let's go do the draw. I'm going to go get the draw, close it off, get everybody's name. It looks like we have 42 entries. That's about right. Okie dokie. Let's go ahead and download the responses in a CSV. That's a comma-separated value spreadsheet. And you have to be a positive and a negative one. That's black and red. That's a good one. You have to be here to win. That sort of goes without saying. So I've already downloaded the spreadsheet. So go ahead and enter all you want now. You're not gonna get on. So where's my downloads? Where are my downloads? Oh, I got to go to this PC. I'm used to a Mac, right? So bear with me. Downloads. There we go. And Polymaker giveaway. There it is. And double click that to open it. Da, 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 there we are, and we have, I'm just going to see if there's any cheaters tonight. I'm going to go ahead and I'm going to sort the data. And I'm going to sort it by this column. Let's just see. Da, 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 and it looks like, is anybody going to be eliminated? Nobody is going to be eliminated. I'm proud of you guys. Nobody cheated. Nobody cheated. There we go. I am going to copy. All right, all right, all right, all right, all right. Okay, and I'm going to go ahead and close that. Let's open the window here. Oh, no, open the window here. Do as I say. And let's go to the wheel. There's the wheel. Okay. Let's give the wheel a preliminary spin. You guys all know what the preliminary spin is about, right? Right? And I got to let you know, nobody, you're out of here. Nobody. There is one here that says, don't mix, don't spin, no winners today. Oh, hopefully we don't land on the don't mix, don't spin, no winners today one, guys. So let's go ahead and spin. I need some music in this, right? I need some music. Oh, luckily. Spin. Okay, 20-second spin is set. There we go. We're going to delete all this stuff. Select them all, delete them all. Let's paste in the names. Bad mic day for the spinner. Oh, that sucks. Okay, 4 mixes and 20-second spin. Here we go. Good luck, everybody. And 1, 2, 3, 4. And here comes the spin. It's probably messing up my microphone. I don't care though. I still sing. And the winner is Petty Ruxpin. Petty Ruxpin, congratulations. Say something in chat. Say something. Congratulations. Oh, so close to you, Jerry. Look at that. Oh, man. Petty Ruxpin. Say hello. Come on, Petty Ruxpin. Da, dun, da, da. I know you're here. I'm sure you're here. We're going to start the clock soon. Uh-oh, he's going to be on another streak. Uh-oh. Petty Ruxpin. Petty Ruxpin, come on, please, say something. I'm going to start a timer. Hey Siri, start a 2-minute timer now.
2 minutes starting now.
Okay, we have 2 minutes. 2 minutes for Petty Ruxpin to speak up. That's plenty of time, and if not, we have to redraw. I'm so sorry, but we do. Oh man, we do if he doesn't speak up. Petty Ruxpin, are you out there? He doesn't show up. You can type at Petty, so he's not taggable. Well, we'll give him. We're going to give him the time. Give him the a fair shake. It's a minute and a half left. Yeah, it's a minute and a half left. That's okay. We got to keep it fair for everybody. Dun 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 ba dun ba dun ba ba. This is the hold music. He's taggable. Petty Ruxpin, where are you? You have to say something. It's the rules of the game. I don't make the rules, okay? Actually, I do. But this is one of the rules. You have to say something. Petty Ruxpin. Anybody knows him, give him a call. PM him, TM him. He's got 50 seconds left. 50 seconds left. Hopefully pooping or something. Well, 2 minutes. Does it take longer than 2 minutes to poop? Well, you should take your phone to poop with you. Okay, come on, Petty Ruxpin. Let's go. Petty Ruxpin. Is he still taggable? Polar Ted Club member. Okay, we have 30 seconds left. 30 seconds, Petty Ruxpin. 30 seconds left. And I apologize, and I know it sucks, but we have to be fair to everybody. We don't show favorites. One of my rules is you got to be here to win. Womp womp. Okay, we have 6 seconds left, Petty Ruxpin. I'm so sorry, bud. But your name's going to come off, and that's the alarm. That is the alarm. Okay. So we have to stop the alarm. Unfortunately, we got to respin, so we're going to remove the name. Okay, and I'm not even going to shuffle. We're just going to spin. Here we go. Good luck, everybody. Good luck for everybody else, yeah. So who's the next one going to be? Womp, womp, womp. If he comes on, don't tell him, because it'll just disappoint him. Here we go. Da Vinci. Now, come on, speak up, Da Vinci. I know you're here. Da Vinci. Yes, there's Da Vinci. Awesome. Congratulations. I am going to send you your link right away. Bear with me. I'm glad we have a winner. Okay, let me just grab your information here while we sit here, and I'm going to send you your Doomer thingy right away. I got the email all set. I think that email came in. Did that email even come in with it? Yes, it did. There's the code. It takes me a second here because the code took a little longer to come in tonight. We're going to copy that. Where's my draft? Is right there. And we're going to paste that in. Now we're going to find your email, Da Vinci. Right here. And I could sort it by alphabetical to make it easier to find, but there you are. And we can copy you. I always double check. I just don't want to send it to the wrong person by mistake. That would be kind of, well, that'd be funny, but not really funny. And we'll paste you in there, and it looks like we have a winner. Send. There we go. It's on its way to you. Yay! And I got an email from AliExpress, which I don't really want to look at right now. There we go. And back to the stream. Where am I? Here I am. There we go. And Done. Congratulations, Da Vinci. There we go. You should have the email right away. There we go. Way to go. Well, we're running out of time to do another one, but hey, we got one done, and let's see, we're at 82% already, so it's charging pretty quick, from 78 to 82% in that little bit of time. Okay, so I can start the other one a little bit here. I love the colors. Like, I love what the red and gray is going to look like. Yeah, that's going to look really good. That's going to look really good. I can actually leave that on, and I've got the red washer. Can I drop that down so it hits properly this time? No, it flipped. It flipped. You got it? Awesome, Da Vinci. I'm glad. Awesome. That's good. Congratulations, man. It's nice. It seems to be a nice variety of people winning. It's not always the same person winning. I don't really have a rule that you can't win twice in a row, something like that. So, but it'd be pretty, if you win twice in a row, you go buy a lottery ticket. And I also have had folks that say spin again, they've already won or they didn't need it. And that's great. That is awesome. Yes, thank you so much, Polymaker, as Da Vinci said, for making this possible every live stream I do. And again, if you guys haven't tried this ASA, we were going to do we're going to do the red one, and I'll finish it off, whenever. But we were going to do a strength test, weren't we, with this second one here to see, because this is very black TPU would look nice with the sand color. Yeah, it would too, wouldn't it? I don't have any black TPU though, do I? I have to check what I have. I may have to order some more TPU because I've only got limited colors. I've got the red TPU. I've got red, white. 3D Printing Canada sent this TPU to me a while ago to try out, which I have done, and I have a lot of left over. And I have some white, but I have very limited amounts of TPU. I know I don't have any black, but black would look great. Black would look good on this too. Would look really cool on this. So, but we were going to do a shatter test on this, right? Because Chris had mentioned that because it's so brittle in the spool form, is it just as brittle in this form? So this is a wooden table. It's going to be loud. Right now it just, so it kind of bounces off the wooden table. If I hit it on a corner, kind of bounces. No, just kind of bounces, and I can't break it. So let's just see, did I crack it here? No. With the battery inside and the end caps installed. You want me to really, okay, and the end caps installed. Okay, well with the end cap, okay, that's a fair trial. I think I dropped the washer out of it. Did I put the red washer in it? Oh, it's right here. Oh, we can, here, let's just do this one. Since this is the one that I've kind of brutalized already. Let's put this on. Put the washer in. Okay, we'll put the battery in. And we'll install this end cap. Let's do this. Okay. Loose. That's with the battery in and everything in it, okay? Let's do this experiment. Let's get this camera. Let's witness this. Let's make it live. Okay. Let's get this live from the floors of DeWitt 3D Studio, of DeWitt Studio, not DeWitt 3D anymore. I don't go by the 3D anymore. I'm just DeWitt. Okay, here we go, live from the studio floor. Oh. Okay, here we go. First we'll drop it. I'm going to go from about 4 feet onto the end, okay? It cross-threaded it a little bit. Oh, it did. Okay, we broke the threads. Okay, we broke the threads. Let's just drop it on the other end and just see. 4 feet. Okay, and this one survived so far. Let's try it again. So I'm about 4 feet in the air, and I'm going to go a little bit of an angle. Okay, Nothing. Let's try it again. Okay, and so far this end has held up really well. Okay, this end didn't hold on too well. Okay, so yeah, this end is totally obliterated, whereas this other end, yeah, so I think that's all we can drop for now. I do not want to damage the battery. So this end took 3 or 4 drops. The top end didn't take very many drops before it shattered. So it broke at the threads. Okay, so let's pull the battery out. And let's just try something here. Oh, thank you so much, another CG. I appreciate that. We have a super chat or something like that. Where is it here? Another CG. Thank you so much. I appreciate that. I don't have a super chat thing anymore. TPU the entire case. Could do that. That could very well would work. Perfect. Yes. But the thing is, don't drop these. The other thing I was going to try, and again, it's going to be loud. Sorry, upstairs. So that's pretty strong. The body of this thing is pretty strong. Where the threads are, okay, the threads break, okay, because the threads are actually obviously the weakest part of this model, okay? So the threads are the weakest part, but the body itself is extremely strong. So the layer adhesion on this is good. This is 4 perimeters. So the layer adhesion of the body itself is good, but of course, if you look where the threads are, we don't have a lot of wall thickness on the threads themselves where the threads meet. Okay, so yeah. Now I think, was there some infill happening on the threads? No, there shouldn't have been any infill happening on the threads. Should outlive the printer. Sorry about that, Petty Ruxpin. Only 3 walls in some spots. Yeah. So, but overall, the body of this thing. So if I were to, oh, okay, I have to hit it hard. I mean, I beat that thing up and I just dented it slightly. So that's strong filament. That is extremely strong filament. Again, the threads are obviously the weakest part, but that held up pretty good considering when you think about that. Now, am I going to be able to get this, am I going to be able to get this out of here? Or am I going to have to reprint my, come on. Oh, and you know what? There is some actual, and I can strengthen these threads actually. There's, if you look, there is actually some infill happening in part of the threads. So I could just actually alter that so that I print the threads at 100% and would probably help. But I guess rule of thumb, don't drop your charger. Oh, there we go. There we go. Don't drop your charger, rule of thumb. There we go. Into the graveyard. Well, that was more fun than starting another one to build, but we will build one. I'm going to see what other color TPUs I have too. But I'm happy with that. I love the combination of this. Actually, I think what I'll do is I may actually print another, I'm going to make another flashlight. I think I'll make another flashlight to match one of these chargers. Right, so I love the clear TPU on the light. Okay, we have the top light, and then we have the side light, which is not nearly as bright, but you know, I can actually stare at the side one without being blinded. I can dial that up with the little potentiometer on the LED controller. But it'd be cool to have this in this with the black caps. I may order some black TPU then. I think the black would look great on that, wouldn't it? So, but yeah, we're good. We're good. I like it. So really good, really great designs there, Chris. I like these things. I will post some pictures of this. I'll post some makes of this, and I'll do any other combinations of colors I make. I will do. We're going to make another one for sure here. I'll use the red caps on this because I think the red and gray go really sharp together. So awesome stuff. Partial design flaw in your opinion? You're going to thicken it up, thicken the threads up. Yeah. If you do, I'll do another one, or I'll reprint it or something. That's the beauty of these things too, though, right? If he designs another one with thicker threads, take it apart, pull it out, put it back in the new one. You've got it. You can't do that with the commercial ones you buy on Amazon and stuff. Really, you can, but you can't do them. So just like the flashlight, something breaks, you print the part again, you put it together, and Bob's your uncle. So, and I actually do have an Uncle Bob. So there we go. A slim version and a fat version. Yeah, the red and gray look great together. Oh, love that. Like if I take these pieces out and just assemble them really quick here, I love the look of this. Love the look of this. Love the look of that. Here we go. Ready? Ugh. 5 more. 4 more. 3 more. 2 more. Oh, I'm done. That would look good with black, though. I'm going to get some black TPU and probably redo those end caps. So awesome. Perfect. Whoop, whoop. Juggle them. There we go. Perfect, perfect, perfect. So look at that. Right on the 2-hour time frame. No pain, no gain. You're right. So let's build some more stuff. No volts, no gain. Ah. Don't bring one of those to the airport. It looks like a... Well, good question. Good question. Could this go? Could you bring this with your carry-on? I don't understand the... what are the laws about batteries? And this is a lithium phosphor, is it? Lithium phosphor... No, lithium ferrite, lithium LiFePO4. Is this carry-onable in your carry-on luggage? Yes, it's under 99 watt hours. Oh, is that the thing? Is that the regulation? Is the watt hours? Lithium iron phosphate. You would have to have it in your carry-on. Okay, so you could carry a power pack like this on the plane. That's pretty cool. But I would guarantee if you walked with this in your hand through security, they're going to take a really close look at it. Because it does look like a boom boom thing, right? So there we go. And they don't like certain batteries in checked. No, and that's just it. Well, I know for a fact that these little guys, these little batteries here are, where did I put the packs? I've got the packs of them here. This little charger uses these batteries, which are, oh, come on. Lithium polymer. Yeah, I think that you're right. Lithium polymer batteries. No, lithium ion rechargeable batteries. These are okay you can put these in carry them on the plane. So most are going to assume it's a dumbbell. Oh, there we go. If they don't, they take it away. I know. Yeah, it's a dumbbell. Yeah, it's just I like to work out while I'm on the plane. 500-gram dumbbell. There we go. Listen, folks, and everybody, thanks for being here. Chris, thanks for being here and kind of guiding me and watching me make mistakes that I have to fix, which is great. That's the only way to learn. Thank you, everybody, for being here. And thank you for the super chat. I appreciate it. I appreciate you all. Imagine seeing someone connect my phone to that at the airport. Yeah, that would be funny. That would be funny. Anyways, you guys, thank you so much. I appreciate you all. We will see you guys next Sunday. Don't know what I'll do. I've got these really cool LEDs. Chris will remember these. I have a ton of these, so I got to make something to do with lights. I need to do something with lights. I have about 6 strips of these things. They're massive. And Chris, you did something with these a long time ago, and I had ordered some and I went overboard. So these are really bright LEDs as well. So yeah, we'll see. We'll do something with them on one of these upcoming streams. But right now I am on an LED kick. So there we go. Okay, you guys have a great week. I appreciate y'all, and talk to you next time. Bye for now.